Hi everyone, and welcome to the second of 4 videos going through some past exam questions on bonding and structure. So if we look at this question, it says we've got solid potassium bromide and ice all exist as lattices. So any kind of solid structure is going to be a lattice. The melting points are shown here. What type of lattice have we got? So potassium is a giant metallic lattice. Potassium bromide is a giant ionic lattice. And then water's a simple covalent molecule. So you think, well, it's not going to make it's not a giant lattice, but it is when it's ice. Yeah, and it just has to be very, very cold for it to form a solid. Okay, and so we'd say it forms a simple molecular lattice. Okay, now simple and lattice seem like they're a contradiction, but it's basically a lattice made up of simple molecules. Okay, they're held together by hydrogen bonds. It's just that it needs to be cold enough for those hydrogen bonds to actually keep it as a solid and not be broken up into a liquid. Okay, so simple molecular lattice. Okay, and then it says explain why there is a difference in the melting points of these three substances. You should refer to the types of particle, the types of forces between the particles, and the relative strength of the forces. Okay, so we're literally just going to do what it says in this question. Okay, so in potassium, what's holding this together? It's a giant metallic lattice. So there is a strong electrostatic attraction. So this is the type of force. And then we need to refer to the particles between K plus ions and delocalized electrons. Okay, so I'm going to bullet point this. We talked about potassium. So in potassium bromide, what have we got here? There's going to be a strong electrostatic attraction again, but it's going to be between oppositely charged ions. And in H2O, then the forces, we already mentioned it when we were talking about it, it's going to be hydrogen bonds. Okay, so we can say they're much weaker, aren't they? There are weak intermolecular forces. And we can say that they're hydrogen bonds between H2O molecules. Okay, and so then we've done it, haven't we? We've talked about the types of particle, so ions and electrons, oppositely charged ions, H2O molecules. Type of force is an electrostatic attraction. It's an electrostatic attraction. It's an intermolecular force. It's a hydrogen bond. And then the relative strengths. We've said strong, and weak, but we can do a bit better than this. If we look at the melting points, we can rank them in order, can't we? So the electrostatic attraction in KBr is the strongest force. Followed by the electrostatic attraction in potassium, and we can then say the hydrogen bonds in H2O are the weakest force. So then we've ranked them in order. Okay, so hopefully that's not too bad. I think if we can just make sure you're really being careful and doing what it's asked you to do. It's very easy to waffle in this type of question. And so hopefully that's a way you can lay it out clearly and say, right, in potassium, what are the particles, what are the forces? Right, what about this one? What are the particles, what are the forces? Just make sure you've actually answered specifically what it's asking you to do. Okay, and then we have this question here. We've got this table to fill in. And it's asking us to talk about the structure, the forces, and the particles. So again, similar kind of question where I go, what are the forces, what are the particles? So lithium's a giant structure because it's a giant metallic lattice. Carbon, diamond, that is a giant structure. We could say like giant covalent lattice, but it looks like giant is going to be good enough to get us the mark here. What force or bond has to be overcome? So in lithium it's a metallic bond. In carbon it's a covalent bond, okay, between carbon atoms. And in fluorine, if fluorine has a simple structure, then it's a simple molecular structure, so it must be an intermolecular force that we have to overcome. And if it's just fluorine, the element, it's going to be London forces. Okay, it's going to be a London force between the fluorine molecules, okay, because it's a simple molecular structure. So that's an answer to this. The particles between which the force is acting are F2 molecules. Okay, it's an intermolecular force. In carbon, we have covalent bonds between what particles? Well, between carbon atoms. And then in lithium, if it's a metallic bond, then the metallic bond is between Li plus ions and delocalized electrons. So just being really accurate with exactly what particles we're talking about.